Example number 4. Calculate the wavelength and energy of radiation emitted for the electronic transition from 6th orbit to 1st orbit of hydrogen atom. So always the lower value will be N1. N1 is equal to 1. N2 is equal to 6 and Z is equal to 1. We have to calculate the energy and wavelength. So we have the formula from Bohr's atomic model, that is delta E is equal to 2.18 into 10 power minus 18 into Z square by 1 by N1 square minus 1 by N2 square. So this is a value which will be in joules. Okay. Now let us substitute here. Delta E is equal to 2.18 into 10 power minus 18 into Z is 1 square divided by 1 by 1 square minus 1 by 6 square. 6 square is 36. So 36 minus 1 is 35. So 35 by 36 into 2.18. If you can do that, you get 2.11 into 10 power minus 18 joules. That's the energy. So if you can do energy, you can eliminate two options because the order is wrong. So now using the energy, let us calculate the wavelength. We know that delta E is equal to h nu, or we can say that delta E is equal to hc by lambda. Our intention is to calculate the wavelength. Wavelength is equal to hc by delta E. H is 6.626 into 10 power minus 34 into C is 3 into 10 power 8 by delta E is nothing but 2.18 into 10 power minus 18. 2.11 into 10 power minus 18. So you just substitute the values. 6.626 into 3, the whole thing divided by 2.11. We get 942. We get how much? 9.42 into 10 power. So this is 26. 34 minus 26 will be minus 8. Minus 8. Minus 8 meters is a unit. So this can be written as 94.2 into 10 power minus 9. 10 power minus 9 is nanometers. So this is close to option C. 93.7 is nothing but 94. Since I have taken all the decimal into consideration, we are getting 94.2. Simple.